Hello and welcome back. In continuation to our previous video, talking about electrical transmission lines, in this video, we'll talk about cables construction, cables layers and material for each layer and their functions. Starting with the main layer, which is the conductor, that would carry the current and withstand the pulling forces. Another layer, which is the conductor shield, that would prevent concentration of the electrical field and ensure close contact with the insulation. Important layer, insulation, which would withstand the different type of electrical stresses. Again, insulation shield that will provide or prevent the concentration of electric field and ensure a free contact with the insulation. Metallic screen or sheath and armor will perform many functions like electrical protection, water tightness, active conductor in the case of short circuit, and it will contribute to the mechanical protection of the cable. Fillers, which create a watertight barrier to avoid water penetration, and the oversheath or the outer sheath that would insulate the metal screen from outside environment and provide mechanical protection for the cable. As we said, that each layer it's made of a different material. Like the conductor is made of copper or aluminum, the conductor screen is made of semiconductor material. Insulation is made either from oil-filled or XLPE. Insulation screen is semiconductor material. We have the fillers, which is made of paper and swallowable powder. Metallic screen or sheath and armor. The metallic screen is made sometimes from copper wires and tape, lead alloy or aluminum, and the armor is made of aluminum. And finally, the oversheath, which is made of polyethylene material or penlevoyl chloride, as we will see later on. So conductor, it comes with different shapes, either round conductor, oval conductor, hollow conductor, strand round conductor, profile wire conductor or profile wire hollow conductor, segmental conductor or a segmental hollow conductor. These all the types of conductor shapes. There are many phenomena that happens to the conductors, like here the skin effect, where the current tends to flow near to the surface of that conductor rather than the center of the conductor. That happens in AC depending on the frequency caused by the magnetic field inside the conductor and creating what is called a skin depth due to the circulating current, eddy current, the circulating eddy current. All of this will result to an AC resistance greater than the DC resistance of the same conductor. Another effect, which is called the proximity effect, when we put two cables beside each other, there will be an effect from one cable to the others, depending on the direction of the current. If the direction is the same, then there will be like the current will flow to the opposite of the presence of that conductor, or there will be like an attraction to the current flow in the case of they are passing opposite the current flow and that cable is opposite to the other cable. Also, this occurs in AC caused by the magnetic field created by the neighboring conductor, resulting in an increased effective resistance. To calculate the DC resistance at a certain temperature, we need to know the resistance at 20 degrees Celsius multiplied by 1 plus alpha, which is the resistance temperature coefficient depending on the material, whether it's copper or aluminum, multiplied by the temperature minus 20. If we get this DC resistance, we can get the AC resistance by multiplying by 1 plus YP plus YS. YP is the proximity effect factor and YS is the skin effect factor. We talked about the conductor screen and the XLPE insulation and insulation screen. It's good to know that all of these three layers are made in one process that is called the triple extrusion method, where there is a machine that will make all the three layers together simultaneously. We can see from this cross-section view that the inner black layer is the conductor screen, the outer black layer is the insulation screen, and in between there is the insulation. In this case, it's an XLPE insulation. We told that the presence of conductor screen will uniform the electrical stresses among the insulation, because if we don't have this conductor screen, the electric field will move like freely, and there will be a concentration that the electrical field will be concentrated at some area, it is less in some other areas. So we would like to uniform it, make it uniform so that we can have like a uniform stresses and reduce the possibilities, either failures or heat spots and so on. To calculate the electric field at a certain point inside the insulation, we are using this equation where U0 is the operating voltage, Rx is the radius at position X, Ra is the external radius over insulation, and Ri is the radius of the inner semiconductive layer. Metallic sheaths have different shapes, like the corrugated sheath, wire and tapes, or a solid sheath. So choosing one of them, it depends on the user selection, and it depends on many factors like the weight, their mechanical strengths, their impacts on the environment, their cost, their possibility to corrode. So selection for which one to go is dependent on the user's preferences or selection. Here is this swillable tape that is composed of paper and swillable powder that would create a barrier to provide water penetration and thereof break down a long cable part. And here is the dotted circle will show the location of these swillable tapes in the cable. It's sometimes between the conductor strands. There is a layer before the conductor screen, over the insulation screen, and over the metallic sheath. Jacket is made of non-conducting thermoplastic material like the polyvinyl chloride, PVC, or polyethylene, like the linear density polyethylene, medium density polyethylene, and high density polyethylene. Why is it important? Because it's to provide many functions, like the electrical function or property, dielectric protection of the screen from the environment. There is a mechanical protection and sidewall bearing pressures that happen during or occur during handling and installation. Also for moisture migration. Moisture penetration is a major contributor to the deterioration of the cable insulation. So jacket can reduce the rate at which moisture migrates into the cable core. Corrosion resistance. Experience has shown that the metallic shield of unjacketed cable will corrode in many types of soil. Over the jacket, we see some marking. What are these marking? So For the first part, it's describe the type of conductor. Second, it's the insulation. Then what type of sheath or material of that sheath. And finally, the material of the jacket. It depends on the cable manufacturer, the type of layers, the type of material in each layer. That's all what we have in this video.